Today I want to address the issue of how to maintain policy neutral science when a lot of pressures are out there to slip into policy biased science. Right off the bat, it's important to recognize that science is biased for many reasons, some of which are very appropriate. But one area that's not appropriate is the area of biasing your science towards a particular policy preference or class of policy preferences. There are many ways that science does become biased. The way we want to focus today is stealth policy advocacy. We call it stealth policy advocacy because the average listener, the average reader, doesn't really know that the science is biased. It sounds like policy neutral science. It's usually presented by people who call themselves scientists, and the average person, and even the average scientist, might just simply ignore the fact that there's, or be unaware of the fact that there is bias in the science. But let's start with a few definitions. First, policy. Policy really is nothing more than a decision or plan of action for accomplishing a desired outcome. It doesn't necessarily have to be complicated. These are the tough choices that people have to make, decision makers, policymakers, usually elected officials or senior bureaucrats appointed by these elected officials. And it's also important to recognize, so far as policy goes and policy deliberations, that science is only one of many elements in these policy deliberations. And it's rather surprising to some scientists that it's not necessarily a very important one. It may be relevant, it may be useful, it may be even essential, but it's not necessarily the most important or the driving factor in policy. Let's talk about science. Science is really a kind of information. But it's information that has four characteristics. It's rational, it relies on our senses. It's systematic, it can be described how you went about it. It's testable, other people can do the same thing. And other people do the same thing you did. In theory, if it's a credible hypothesis or conclusion, they're going to get roughly the same answer. Now this contrasts with other kinds of knowledge, faith-based knowledge, traditional knowledge, experiential knowledge of all types. Fishermen may fish in an area for many, many generations and have tremendous knowledge. People may live in a particular area, land, for many, many generations and have certain kinds of knowledge, all of which is relevant, and potentially useful. But it's not science. Today we're going to focus on that information that we call science. Well, policy neutral science is just that. It's science that is presented as even-handed, does not tend to be subtly slanted or unsubtly slanted towards a particular policy preference. This gets at the idea that Darwin pushed, that a scientist, and in this case be a policy analyst too, needs to have a heart of stone. In other words, they don't really care, they're not really interested in which of the many policy options is chosen. Their job in life is to provide policy relevant and policy neutral science to help decision makers make the choice, not to subtly influence the choice. In contrast, policy bias science is bias that is presented or even carried out that tends to subtly favor a particular policy preference or class of policy preferences. Oftentimes, policy advocates, perfectly legitimate activity to advocate for policy preferences, but some advocates will wrap themselves in science, and they'll even call themselves scientists, and they'll operate like scientists, and they'll pitch their policy preferences as if the science compelled that particular choice. So a lot of times you have the phenomenon out there of advocates masquerading as scientists. And especially for the general public, they don't have a clue who's a, quote, real scientist and who's a policy advocate who's using science to pitch a policy preference. Normative science. Normative science in some sense really isn't science because it doesn't meet the four characteristics of science. But it's information that's developed or presented or interpreted based on an assumed, and it's usually unstated or at least hidden, a preference for a policy or class of policy. In other words, that's science or information that looks like science, it sounds like science, is presented by people who would have you believe they're policy neutral scientists, but in fact it's really scientists that subtly pushes a policy preference. And oftentimes this slips by, and this type of science, this normative science, is treated and regarded as if it was real science, of which it is definitely not. Well, what exactly is normative science? The definition is the one I just stated. It's very clear cut. And the take home message here is really it's very easy to slip into normative science and not even realize it. And this is because that science really it has implied ought statements or should statements. In other words, here's the scientific information, but it's couched in such a way that the policy choice is really fairly obvious. In other words, here's what society should do, or here's what society ought to do. And that, of course, is not science. That's policy advocacy. Or, as the saying goes, it's advocacy wrapped in science. Well, how does regular science become normative science? Let's imagine a hypothetical case here that we have a wind farm being built in, say, the Mojave Desert in Southern California. And you have a contract to assess the ecological effect of this wind farm and this transmission line, which you see in the foreground here, on, say, bighorn sheep. Okay? That's a statement of going out, get the information, do the appropriate scientific studies, and provide people with a statement of if you build this wind farm and if you build this transmission line from the Mojave Desert to Los Angeles, here are the likely ecological effects of these lines and transmission lines and wind farm on bighorn sheep. No assumed policy preference. In some sense, as a scientist, you don't really have a dog in the fight. Whether they build this wind farm and these transmission lines or not is really not your concern. Your concern is to provide the best available science relative to someone else answering that question. In contrast, you could present the same information that you gathered in a way that has an ought statement or a should statement in it. And that is, for example, if you said things like, by the way, this area will be degraded. What does that imply? It implies that one condition of the habitat is better or worse than another. It may be worse habitat for bighorn sheep, but that is basically an assumed policy preference. Who said the policy preference is to protect bighorn sheep? That's not something for scientists to say. That's for something for policymakers. A scientist would use words like change. This area will change the environment in the following ways, and this is likely to be the effect on bighorn sheep. Now, if you don't, as a policymaker or the public, if you don't like those effects, you may call it degraded or whatever you want to call it, but that's not for scientists to say. That's for policymakers or policy advocates to say, not for scientists. Passing off normative science as if it was regular or traditional or real science is not okay. I argue that slipping into normative science is in fact a form of policy advocacy, pure and simple. There's nothing wrong with policy advocates. Some of the largest big environmental advocacy organizations and others are advocates, perfectly fine in a democracy. But the science ought to remain policy relevant, but policy neutral. And worse than all this, this is actually stealth policy advocacy, because the audience really doesn't realize that what appears to be policy neutral science is in fact a form of policy advocacy. And when people figure this out, what does that do for trust in the impartiality of scientists? A lot of folks right now, if you look at the polling data across the country, a lot of folks don't trust scientists to be policy neutral. They think they basically are pushing policy preferences. And so as a result, science collectively, and scientists in particular, tend to get dismissed as just another form of policy advocates. Well, how does in practice regular science become normative science? And I would submit that it's incredibly easy to do. And let me just give a few examples of how what is normally perceived to be traditional or regular science just ever so easily slips into being normative. It's often difficult to detect even for experienced policymakers or even policy analysts. And most of us live in a disciplinary bubble, a tribe, if you will. We don't tend to get challenged with the diversity of thought because we live in a group of scientists who tend to be of the same mindset, or people that tend to be of the same mindset politically and socially and so forth. And this has been described sometimes as the Facebook syndrome, because the algorithms that drive Facebook and Google and Bing and all the rest of them are driven by your behavior. And so pretty soon your news feed is based on what they think you are most likely to gravitate to. And that's why the results of elections, in part, are such a shock to so many people, because everybody they know supports the candidate that they think is reasonable and the best. And so we have the Facebook, the silo effect of these media-driven systems like Facebook and Google and so on. And we don't we tend to work someplace where everybody tends to be of the same philosophical mindset. So we don't tend to get challenged with a great intellectual diversity that might have been traditionally true when we didn't have such algorithm-driven systems. Well, let's look at some commonly assumed policy preferences that get embedded in science. And these are probably, in my view, the most typical ones, but they're certainly not the only ones. A few examples. One assumption is, scientifically, that native species and non-native species are, in fact, of different priority. Here we have, on the left, a rainbow trout, which is very common in the United States, native species. On the right, we have a brown trout, very popular among fishermen, as is rainbow trout on the left. And so, which is more important to the public? I mean, the rainbow trout supports a tremendous recreational fishing pressure, as does the brown trout. Brown trout's widely distributed across the United States. But in fact, the brown trout came from Europe, and it's been introduced. It's not native to North America, whereas the rainbow trout on the left is native. Now, policy-wise, which one is preferred? Well, that depends. I mean, fishermen tend to like them both. They're similar, but they are different in a number of different characteristics. Other people might say, well, we just want to give non-native species the leg up. That's our policy preference, and that's certainly reasonable, but it's not a scientific question. So policy-wise, which is preferred is based on a value judgment. And that value judgment comes from the public or decision makers or the law. It does not come from scientific information. Scientific information might inform the public, it might inform decision makers, but it's not going to decide among the competing values which is more important or if they're equally important. So here's an example of the fact that something other than science decides whether native species or non-native species are more important. What decides if a species is good or bad? Again, largely a value choice. Let's use some examples. Here we have a honeybee. It's two honeybees. Now, you're all aware that honeybees are not doing that well these days. Honeybees are extremely important in agriculture, particularly certain kinds of agriculture. And in fact, when people realize that honeybees are not doing well, they tend to be very unhappy about that. Well, the fact is that honeybees are not a native species. This is an introduced species, extremely important, but again, an introduced species. And when people look at their bad state right now, or less than desirable state right now, they don't feel too happy about it. Here we have a zebra mussels, and this is about the size of a dime. Zebra mussels tend to be very, very prolific, and they have big clusters of these things, and they tend to hang around or colonize water supply areas, sewer treatment plants, drinking water plants, and so forth. Now, they're not all bad about zebra mussels. They do tend to do a number on water facilities, but they also filter feed, and so they tend to clarify the water. And so waters where these are abundant tend to be clearer than those where they're not. But how many feel sad about zebra mussels? No one. In fact, almost everybody would just soon got zebra mussels got rid of. Another non-native species. Here we have a horse in North America, the wild horse, Mustang, the romantic species of the West. And if you ever have an opportunity to work with the Bureau of Land Management on wild horse management, be careful about going into it, because about half the people out there feel that horses ought to be eradicated from the Wild West. They basically compete with big game, elk, and so on for food. Hunters don't like them. And the other half feel that, no, this is a species that has a tremendous legacy in the West and ought to be protected at all costs. Another non-native species. So what's the take-home message here? Whether these species are good or bad is a value choice. It is not based on science. So don't look for scientists to tell you whether these species ought to be eradicated or ought to be supported or ought to be protected or whatever. Scientists can provide information that might help you as policymakers or the public make that choice, but it's not one for scientists to make. Well, another broader question is science itself typically, as we typically see it these days, tend to be biased towards natural? By natural, I mean pristine, not altered at all by humans or minimally altered. For example, let's look at two pieces of real estate in the upper Midwest, and just imagine these are adjacent pieces, so they are essentially identical. The one on the left is a tall grass prairie. It's pretty much the way tall grass prairies have been for hundreds of years, if not thousands. And the one on the right is the same piece of land, right next to it at least, that's been converted to a cornfield, and it's doing really well. This person pays taxes on the property and makes an income off it. Well, is the one on the left healthy and the one on the right improved? If you go on the tax rolls, for example, you'll see the one on the right called improved because somebody has done something to the property to make it more valuable. But the flip side is the one on the left is healthy in the sense that native species are there and doing well. Native species don't do so well on the one on the right, but other species do. So the question really is who decides? And I would argue that it's not a scientific issue. Science is an input in the process, but that's all. If your public policy goal is to create conservation easements, the one on the right, the left, is the appropriate one. And if your priority is to produce ethanol to reduce dependence on foreign oil, the one on the right may be the priority. So terms such as healthy, improved, degraded, productive, these are terms that usually should alert you to the fact that somebody has slipped into normative science. These terms are perfectly reasonable to use in advocacy, and advocates can use whatever terms they want to help sell their policy preferences. But they're not terms that are appropriate to use in science. Well, I'll make a broader assertion, and that is these days, I think what passes for science, particularly in ecological fields, tends to be biased towards natural. The assumption basically is that unaltered ecosystems, i.e. pristine ecosystems, are just inherently superior. They are different, obviously, than altered ecosystems, but I would argue that in science, they're not better or worse until you imply a value preference. And I think a broad value preference that I see in science these days is the fact that somehow unaltered ecosystems are just superior. It's almost it's a point of religious faith. Well, how do I determine if you're the scientist, how do you determine if you have slipped into normative science? I think the best test is not what you intend to convey, not what you intend to imply. Ask others what policy message they hear or they read or they interpret when they read your speech or listen to your speech or your text. It's what other people hear or what other people learn from your comments, whether what you're trying to convey comes across as pushing a policy preference or not. Your intent may be noble, but if that's not what people hear, you're not communicating well. And when you see words in science, they're fine in advocacy, no problem. But in science, words like health ecosystem, sick ecosystem, ecological crisis, biological integrity, degraded. The question I would always say is, how do readers interpret these words? And I think in general, when readers see these kinds of words, their antennae ought to go up and they say, wait a second, I think this scientist has slipped into normative science. So my take-home message, several. Be careful what message is being conveyed when science is presented. And I would reiterate the second point. It's not what you intend to convey as a scientist, but rather what the listener or reader interprets. You may not be intending to convey a policy preference, but if your reader interprets it that way, you need to sharpen your message to make sure your information comes across as being neutral, policy unbiased, rather than policy biased. Working at the science-policy interface is interesting, challenging, and can be very rewarding to people. And good luck if you do get involved in these kinds of issues.